What is PAT? PAT actually is called Pollution in the Atmosphere and Transport Model System. PAT can be defined as three-dimension air quality model system, which is emission process model, 50 generation, Pennsylvania State University Nation Center from Atmosphere Research (NCR), Mascot Scale Modeling System (MM5), and Florian Photochemical and Transport Model. This model has been verified by HKEPD from air pollution in Hong Kong and PRD region. For the next slide, I will present about the problem statement. Pearl River Delta have shown a largest increase atmospheric emissions. It took only 5 years from 1990 until 1995. Increase the emission by 21% over than PDR region. And it expect increase to 100% to 160% from 5 years expected from 1995 to 2020. From the result, we can conclude Hong Kong and PDR have been in problem suffering from frequent and severe air pollution.
Objective of this case study is to investigate the concentration of air pollutants in Hong Kong between 1994 until 2004. Then, to investigate the O3 using the PATH modeling system in Hong Kong from 2000 to 2004. And lastly, to study the different weather pattern which can affect the O3 episode in Hong Kong using the air quality model. So, for the location of the research is at Hong Kong, that is situated at the southeastern coast of China and it joins the rapid developing Pearl River Delta PRD region.
Based on the picture, much larger urban areas in 2003 compared with condition in 1993. The area designated as urban increased by a factor of 24. With development and urbanization, anthropogenic emissions have increased significantly, and local meteorological conditions, including urban heat island and coastal land sea breeze effect, have changed remarkably. Urbanization strengthens sea breeze circulation. This study also suggested that air pollution meteorology of the PRD region is strongly influenced by the local sea breeze circulation. This recirculation of pollution requires further investigation.
Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Arif Fikri. Today I'll be continuing what my colleague just presented just before. So today I'll be talking about the differentiate between the emission from Pearl River Delta and Hong Kong itself. So we are gonna take a look about which is the most sources that giving the most pollution. So this is a percentage of contribution from individual sources to total NOx and VOC emission. So point and mobile sources contribute the majority of NOx emission, which is 75% in Pearl River Delta and 77% in Hong Kong. For area and shipping sources, account for the remaining part 25% in the PRD and 23% in Hong Kong. And the contributor for VOC emission for area, mobile and bionic jet sources are 99% in Pearl River Delta and 98% in Hong Kong. Area sources have a higher percentage of contribution in Hong Kong than the PRD, which is 51% in Hong Kong and versus 28% in the PRD. So for biogenic sources, they contribute 3 times more VOC in the PRD than in Hong Kong in terms of percentage contribution, which is 34% in PRD versus 13% in Hong Kong. Overall, the contribution for individual emission sources are similar in Hong Kong and PRD, but for NOx emission, there is a huge difference for VOC emission. Finally, we also note that the ratio of VOC to NOx is 1.555 in PRD, approximately twice that in Hong Kong. So we can see that this is the different PRD, different NOx and VOC emission from the table. So this is the table for each individual contributors, which is calculated in units per ton per day. Next, O3 production is associated with specific weather conditions such as high temperature, strong solar radiation, and high humidity, and so on. Those conditions follow different hypnotic pattern. The climate of Hong Kong is governed by the East Asian monsoon. All three episodes are most common frequent weather system affecting Hong Kong include tropical cyclone or typhoon over the South China Sea of the North-Southern Pacific regional high pressure system. Anticyclone to the north over mainland China and low pressure system through to the south and east over the South China Sea. The results show that two-thirds of the O3 production within the lower atmospheric boundary layer attribute to regional transport from the PRD region during one typhoon-related hypnotic pattern of O3 episode. This O3 episode related to the presence of Typhoon Sinlaku. When the typhoon was located to the east of Taiwan, the large-scale subsidence effect in the periphery made to the air over Hong Kong and the PRD region very stable, which brought in weather conditions conducive to O3 formation and build-up. High temperature, clear sky with strong solar radiation, with surface northerly winds and a stable lower atmospheric boundary with ABL. So this is the performance statistic for MM5 on modeling surface wind speed, and wind direction during 4 differentiate synoptic pattern of O3 episode in Hong Kong. As we can see, we call each pattern with different name, which is C, A, AC, and T. So the episode having a different timeline. So finally, for the last part, the path model system is applied to study 54 or 3 episodes from 2000 to 2024. The performance of both models is evaluated in the same way, including temporal variation, spatial distribution, and statistical calculation. 4 episodes are cases between this number, which is dated by its episode. So as I said before, they are being recognized as different cases. So the percentage contribution from horizontal aviation versus those from local chemical production for 54 or 3 episode during 2000 to 2024. About 33%, 70%, and 28% of O3 episode in the past 5 years, which is 2000 to 2008, resulted that from these 3 hypnotic patterns respectively. The remaining high O3 episode 22% happened when a low pressure trough was found to the east of Hong Kong over the South China Sea. In summary, regional formation of O3 is expected to be more prominent under a C, A, and SC hypnotic condition, whereas O3 is preferentially formed under the T condition, and this is likely the reason why we see so much stronger horizontal aviation effect during C, A, and SC, not during condition T. So this is the type of frequency of O3 episode days that is associated with weather in Hong Kong and between each city. Around the timeline is between 2000 and 2024, as we can see. So that is all from me. Thank you.
For the conclusion, the path model system is used to investigate 54 or 3 episodes during 2000 until 2004. A more up-to-date and higher resolution land use data set is used to replace that in the standard system over Hong Kong and PRT. The surface or tree simulation are evaluated through direct observation simulation, comparisons, and also by statistical methods. The results show reasonable performance of the surface or tree simulation with respect to the criteria set by UFEPA, such as the normalized bias and gross error. These studies show that systematic and comprehensive application of integrated process analysis can be used to identify and summarize the salient features of specific type of quality air events. This approach is much more powerful than individual case study for gaining a generic understanding of air quality events.